going to do is, so I just go ahead and I talk about the arc length for the vector value function. So this is it. If you have a vector value function, if r of t is going to be x of t, y of t, and z of t. If this is going to be the case, of course, is differentiable. Is going to be differentiable. Again, differentiable with the derivative, okay, with r prime of t, which is going to be x prime of t, y prime of t, and the z prime of t. Okay, if this is going to be the case, then the arc length, of that space curve, okay, of the curve, the curve r of t from two values for the t equal to the a, okay, from t equal to the a to t equal to b, t equal to the b is going to be given by that extension that I formed. Okay, that's it. The arc length is going to be integral from a to b. Okay, so this is going to be, in fact, the norm of the, you know that the norm of the r prime of t was a tangent line, or that's velocity, this norm, but a speed, if you like. So that's in short, but if you extend it, that's the formula that we predicted. You know that the norm would be the square root of, okay, x prime of t squared plus y prime of t squared and plus z prime of t squared, then the t dt. So that would be the formula for the arc length. That's going to be used all through the chapter 15. Okay, in chapter 15, we are going to have line integrals, which use in physics, and depends on this formula for all the problems that you're going to have. Okay, for the time being, just, a couple of, just a function would be given to you, find the arc length. But in future, this would be part of the deal. We are going to have something called a surface integral, line integral in chapter 15. And all of them depends on the, on the arc length. Okay, question? Just the function would be given. There is a little bit of algebra involved because this radical, you see, you do this algebraic operation here. Then if you be able to simplify this radical, your final integral is going to be easy. Otherwise, it's going to be a little bit complicated. You can use the, most of the time, substitution method, or there are various times that we can't do it and we use calculator. But the one that you are going to see, it's doable if you like, okay? So you have to give us the method that you are going to use. So the function, we give you one of them on this, on the test. Okay, so we want to find the arc length. We're not going to do much about it for the time being. Find the arc length. Okay, arc length of this function, r of t is equal to, again, this is the best case because this is helix, cosine of the 3t and the sine of the 3t and the 3t, and you want to do it between 0 and 2 pi. Okay. Anytime you see the helix, this is easy case. Then I give you another one to show you there was algebra involved. Okay, there you are. You know the formula. That's in short term. The formula would be 0 to 2 pi in this case. A speed, okay, the norm of the r prime of t dt. So we usually find that norm of the r prime of t and we come back and we integrate it. Okay, carefully differentiate it. So that give you r prime of t, which is going to be equal to the cosine of the 3t, derivative of cosine negative sine. You have to multiply that by 3, so that give you negative 3 sine of the 3t. Okay, this is going to be the 1, so this is going to be 3 cosine of the 3t, and this would be 3. So that give you your r prime. Okay, find the norm of the r prime. So we go for the norm of the r prime of t. Okay. We go for the norm of the r prime of t, which is going to be, the square root of negative 3 sine of the 3t squared. Okay, plus 3 cosine of the 3t squared and the 3 squared. You continue simplifying. So that gives you 9 sine squared of the 3t and the 9 cosine squared of the 3t and the 9. Okay, you factor out the 9, that gives you, as usual, sine squared plus cosine squared. Okay, you can do it right away, I just explain it. So that's going to be sine square of the 3t plus cosine square of the 3t and the 9 here. So this would be 1. Okay, so that would be 1. So that you take you to the radical 9 plus 9, which is a radical 18. We don't use calculator to decimal to estimate it. We just simplify it if we can. 18 is 9 times 2. So that would be 3 radical 2. Okay, so that would be the speed, the norm of the r prime of t. Then you just, easily integrable. Okay, so put it inside this formula. 0 to pi would be just 2 pi times this one over here. Okay, I'll go to the next page to explain it, to finish it. Okay, so my arc length is going to be the following. So the L is going to be integral from 0 to 2 pi and the speed of the 3 radical 2. Okay, dt. So that would be 3 radical 2 times t going from 0 to 2 pi. So we just put the 2 pi, we give you the result. So it's going to be 3 radical 2 times the 2 pi. So the result would be 6 pi radical 2. And we are happy to write it down in this form. 6 pi radical 2. Of course, you can use your calculator at the end and estimate it if you like. Okay, so that would be the straightforward one. Any question? Now, to show you that the algebra that's going to be involved, I'll show you one of the problem of your book. Somebody asked me this one, so I just remind you. Are you ready? This must be, I think this is from 12.3, and this must be problem 6. They ask you for the arc length of this function, okay? So find the arc length, okay, of this function. The function is r of t equal to t squared times I plus 9tj, okay, plus 4t to the 3/2 of k, and your t is going to be between 1 and 4. Let's see what is special about this one. Okay, again, find the speed first, r prime, norm of the r prime, and then do it. So the solution is going to be, so the formula is going to be L integrating from 1 to 4 of the norm of the r prime of t dt. Okay, so that's going to be your formula. So differentiate it. So r prime of t, you can keep it as is, differentiate the component. So the t squared would be 2t, so we get a 2ti. Okay, and the second one, the lift of the 9t would be 9. So we get the 9j. And over here, you get 4 times 3 half t to the 1 down, which is going to be 1 half times k. So the r prime of t is 2ti, 9j, and the 4 and the 2 would be simplified. That gave you 6t to the 1 half of k. So that's going to be your r prime. Okay, if you find the norm, so the norm of the r prime of t is going to be equal to that square root. The square root component is going to be 2t squared. Okay, 9 squared, and 6t to the 1 half all squared. Okay, carefully square it. So that you end up with, that's going to be 4t squared, AD1. Okay, that 6 squared would be 36. 36. Okay, t to the 1 half squared, you know that you multiply the powers together. So 1 half times 2 would be 1. So that gives you a t. You see, this is going to be the case. You see, try to see if this is going to be perfectly squared. So most of the time it's the case. So you check it, simplify it in the problems that we have. Most of them is the case, okay, at this level. So if you want to have a perfect square, you need a square here. You see, so that would be the square of the 2t. Okay, and this is the square of the 9. So you check to see if this is twice of the first times second. 2 times 2 would be 4, 4 times 9 would be 36. Okay, so this is going to be 2t plus 9 all squared. So most of them are going to be of this category at this level. Okay, so try to find it. That would be very good. You know, we simplify it before we go into the integration. Okay, so this is going to be the case. So we have a 2t plus 9 all squared, and you take the square root, that will be 2t plus 9. And you are not going to worry about using the absolute value, because you are going to be between t is going to be between 1 and 4. And when you are between 1 and 4, 2t plus 9 is a positive number. You know that when you take the square root, it's going to be the absolute value of 2t plus 9. But t is positive, so nothing to worry about. Okay, so I just emphasize that the t is between 1 and 4. Okay, any question? Now it's easy to integrate. So it's not going to be complicated. If you're getting complicated on the test, probably you miss something. So this is it. L is going to be 1 to 4 now. And that is going to be our formula. Okay, just remind you, it's a speed. Now it's going to be 1 to 4, and the function is simply 2t plus 9. Okay, it's going to be 2t plus 9 dt, which is going to be, okay, easy function to integrate. So integrated is going to be equal to 2t squared over 2. Okay, and the plus 9t. It's a definite integral. It's going to be from 1 to 4. Just substitute and get the final answer. Okay, so these two would cancel out. So that make it into the 4 squared. 4 squared plus 9 times 4 minus, if you put t equal to 1, so that gives 1 plus 9. So this is going to be equal to the 1636. 1636 minus 10. 42 is going to be the final answer. So L is equal to the 42. Okay, so expect to be smooth operations. The one in your book, sometimes the integral is impossible to find. Okay, and this is going to be, what's the question? We just, that's it. That's the one, this is going to be the one, and just substitute. That 3060, you see the 3060 is part of that perfect square that we have. That's one. Thanks, Danny. That's one. Okay, so L would be 42. So there are some of them in your book. They just give you a hint that you may have to use your calculator. So this means that integral is not going to be possible to find. Okay, because it's a definite integral, TI 33, 34, give you the result right away. But the one that you are going to have on the test, we are going to deal with, are always can be done, and you have to integrate it for us, okay? So the substitution, but this is very popular, that try to find the completed square, okay? So this is the Auckland for the time being. You're not going to see quite a lot, but you get quite a lot. When you get chapter 15, you do this one for every problem that we are going to have on that level. Any question? Now, we are almost done with everything we need for future. There is only one topic over here that would be interesting for application. Depends which discipline are going to be in future. You may use it, but we are not going to use it in this course. So it's a one shot. I'm going to talk about it. And we give you one question on the test. It's easy question. There is a formula for the curvature. You must make sure that you know the formula, and we already talked about it. One page, double-sided, any formula you like, you can take with you to the exam, okay, for this test or for any test and the final exam. So this is one of those that the one that you have to carry with yourself, okay? So this is it. What is going to be curvature? It's interesting from application point of view. Okay, that's it, the curvature. Curvature of a curve, if you like. You see, the curvature, when you drive, you get to the curve, you see with your car. The car automatically will do the job because the car is already designed to be able to do the curve. So the curvature is going to be a measurement. It's a measurement to tell you how you're going to bend, if you like, when you travel. So that measurement is going to be called a curvature. And of course, it's a curve. So your curve would have an equation. The equation of your curve is going to be a vector valued function. So we'd like to find the formula for the curvature. That's it. That's our job that we're going to do it. So it's very important. It's used in application, okay, application in designing the roads, freeways, roller coasters, etc. So I'll just give you a brief description. And the formula, algebraically is nice. You can have lots of formulas dealing with the curvature, but we don't need them really. Just need just this main one. For future, in case it depends on your discipline, in case you need it. But we are not going to use it in this course. But from a research point of view, there are quite interesting problems related, because it's important when you want to design those application. You get a kind of different, let me write it down and explain it for you. Okay, so what's a curvature? Is a measurement, is going to be a measure, is a ruler, if you like, for the roads. Measure of how much, okay, how much a curve bends, curvature. That's it. Of course, it's used in science quite a lot. It is used to study, to study the geometric property. Okay, to use geometric properties of curves. And it has application Okay, applications in areas like areas as this is it. The famous one is highways, design of the freeways, highways, designing of roller coasters. Okay, roller coaster design. And of course, optics, quite a lot, and eye surgery. Eye surgery. So as you can see, it would have extensive application that that need to be studied. Now a mathematical part. Formula. The curve would have a equation. So if r of t is going to be x of t, okay, y of t, z of t, we give you one of them and we ask you to find the curvature. Of course, it's differentiable if it's going to be differentiable with, it must be a smooth curve, so the r prime is never zero. If this is going to be the case, then the curvature would be defined by the following. Then the curvature of the path of the curve of the path of RT is going to be defined by this is it. The curvature is a kind of a K. Okay, curvature of T is like a chi. Okay, is going to be, remember the unit tangent vector T prime of T. That's T of T is the unit tangent vector. Okay, is the tangent vector which you normalize, you differentiate it, then you get the norm, and you divide it by the norm of the r prime of t. This is going to be the case. Okay, the bottom one is just the tangent vector, the velocity. The top one is a kind of acceleration, if you like. And this formula is long formula to handle, or not easy to handle, but it's very nice if you are interested in. We can substitute the formula. I prove it when we are in person, and it can be proof that this formula can be simplified. Not difficult. It's interesting if you are interested in proof. It can be proved that this is the version that we're going to use, unless you don't like it. You see the curvature. If you do the algebra of all these, the top would end up with it. So the norm of the r prime of t cross r double prime of t, and the cross product of these two vectors divided by the norm of the r prime of t, okay, all cube. That's a popular form of the formula for the curvature that we're going to use. Okay, you have only one case, so you better use the second one. So make sure you have it, okay, and be ready to use it. It's a good practice for the for the cross product. Okay, so there you are. Example: the equation of a curve would be given. They ask for the curvature. So find the curvature of the space curve with this equation: r of t equal to ti, t plus t squared times j plus t cube times k. That's it. Sometimes they give them, remember this is a function. You see the curvature is a function, so they can, you can talk about minimizing this function, Okay, you can have various problems or various questions when you're dealing with this. But again, we are not going to be much be involved. So this is, in this case, it's straightforward. Just you have to find this quantity r prime of t or double prime of t, just find the cross product, substitute to get the numbers. If there is going to be a t involved, that would be easier, but not in this case. Okay, so just operate to get your result. Okay, so I'm going to differentiate it to get the r prime. I have to find all those parts. So r prime of t, you differentiate it, that give you I, derivative of t is 1. So that give you 2t times j, and that would be 3t squared times k. So that would be r prime. So you need r double prime. So differentiate it again. So you get a 0 here. Okay, 0 derivative of 2t would be 2, so 2j. And the other one would be 6t. Okay, 6tk. So that gives you 2j plus 6tk. So I have the r prime, r double prime. I have to find the dot cross product. So find the cross product. Remember, you need the matrix r prime of t cross r double prime of t is going to be the determinant of this matrix. The first part was I, j, k. And you have to go with the r prime of the r double prime. So the r prime, the components are 1, okay, 1, 2t, and the 3t squared. Then you go with the r double prime, the component, there is no I, so it's going to be 0. Okay, the coefficient of the j is going to be 2. The coefficient of the k would be 6t. So you have to find this determinant and then get the norm. Okay, remember, distribute that to get the, from the first row. So this is going to be equal to, okay, it's going to be equal to the I times across the first row and this first column. So it's going to be cross multiply 2t's, that give you 12t squared. Okay, minus 6t squared. So that's the first part, minus j times. Eliminate the first row, second column. So that's give you 1 minus 1 times 60 would be 60 minus 0. Okay, then plus k times. So eliminate these two. So that gives you just 1 times 2, which is going to be 2 minus 0. Okay, so that gives you 2 minus 0. So if you simplify it, so the final answer is going to be, so these two over here, okay, that gives you 6t squared I, 6t squared I. The j part would be minus 6tj. Okay, and the last part would be 2k. If they give you a specific number, you just substitute the numbers, but you don't have it. Okay, so I got the top, the cross product, then I have to find the norm. Have this, okay, so are you done? I'm going to the next page, continue. You're taking the norm and then taking care of the bottom one and just get the result. Okay, so this is it. So I continue taking the norm. So that gives me the norm of the r prime of t cross r double prime of t. So that would be the square root of the square of those components. So the component that we have is 6t squared all squared. Okay, plus negative 6t all squared and the 2 squared. Okay, and simplify it. So that gives you 36t to the 4th, and that would be 36t squared and 4. Okay, for this case, nothing to simplify. You can simplify it a little bit. We can do it at the end. Okay, then you have to find the norm. That's the top for the formula. The bottom one, you need the norm of the r prime of t. Okay, so we get the norm of the r prime of t. The square of the component of the r prime was 1 squared plus 2t squared plus 3t squared. I got the component. Okay, so that give you 1 plus 4t squared plus 9t squared. So we put them together. I'm sorry, that's I think that's a 3t squared. 3t squared, that give you to the fourth. 1 plus 4t squared plus 9t to the fourth. And we cannot simplify it. When there's not going to be a number, it is not going to be lots of fun. So that's it, the curvature. The curvature, I just repeat the formula. It's going to be the norm of the, okay, norm of the r prime of t cross r double prime of t divided by norm of the r prime of t, everything cubed. So this is the way we write it down usually. The curvature is going to be, the top one is the one that you have, okay? It's a 36t to the 4, 36t squared plus 4. And the bottom one, we write this one as 1 plus 4t squared plus 9t to the 4th, everything to the 3 half. You can't do much about it really. You can factor out the 4 if you like. But in this case is, so if you pick out the 4, you factor out the 4, you take it out, that give you 2. So that give you 9t to the 4th, 9t squared plus 1. And divided by 1 plus 9, 1 plus 4t squared, 9t to the 4th. Everything to the 3. So that give you the curvature, curvature function really to give you the result. Then you can do all sorts of things with this function. You can evaluate it at some specific number. You can differentiate it to find out where the curvature is going to be minimum. Okay, this is the way they use it. And so you need to find it first, and then you just talk about it to get these results. Okay, then you can specialize it in different easy cases. So I'm going to consider just one of them. No, this is the best we can do. You cannot do anything else to simplify. No, the simplification is done over here. You can't do anything else about it. Now, the part which is going to be interesting and if you wanted to see it is the special case. The case are going to be what's going to be curvature of a circle. Okay. So what's going to be, so that would be the interesting parts that we're going to consider. Otherwise, I just wanted to show you how you're going to apply it in science, okay, in everyday life. But evaluation, this is the one. Okay, let's see what's going to be curvature of a circle. So what's going to be curvature? Okay, we want to check. And what is going to be curvature of a circle? To see how we're going to do it. Okay, curvature of a circle. You see, curvature of a circle. If you go around, around the square or roundabout, when there is a circle, which one is going to be easier to go? The one with the, you see, I just give you an idea. Look at this one for the curvature of a circle. Suppose you have these two circles. And if you drive your car, which one is going to be easier? The first one or the second one? When you drive to roundabout. of course, the second one. Yes, you are right. The second one. The second one is going to be easier. So it's going to be easier because you see, if you consider the radius of this to be equal to the r, you see we can prove that the curvature is a reciprocal of a radius. So the curvature of a circle is always 1 over r. So as you can see, this circle would have a smaller, okay, this would have the smaller radius, so the curvature is going to be longer. So that's the one that they like. So we can prove it, we prove it for you right away now that this is going to be the case. And this is the one they are going to use in order to measure the curvature in everyday life. If you want to design something, and this is the way they do it. You see, if you have a curve, suppose you're driving along the Ortega highway, if you like. If this is going to be the case, the way they're going to measure it, if you want to measure the curvature at this point, so what they do, they are going to consider a circle here. So we get the circle at this point. You see, it's going to be a circle. So then they measure the curvature of this circle here. And we know that the curvature of this circle, you see, we know that the curvature of this circle, K is going to be equal to the 1 over R. So we can show that the curvature of the curve at this point is going to be exactly the same as the curvature of the circle. Okay, so at any point, they move this circle. If you move the circle over here, then you're going to do the same thing. So these are going to be in various places. You're just moving along with this, with this circle. So this is this circle that they are going to be interested in. This circle, they refer to the, I'm going to introduce one. We call it kissing circle, if you like. So we move it around and there is going to be measurements. They quickly identify that circle. We can find the equation of this circle for you. Okay, it's not going to be difficult to find. Okay, I'm going to show you, just give you a brief idea, because we are not going to do anything about it. So just give you something mathematically interesting to remember, although we are not going to question you, but it's nice to know the application of these ideas, okay? In case you are going to be doing something in future related to this part. Okay, so let's find out what's going to be the curvature of a circle first. Then I show you and I introduce that circle for you, and then we are done. Okay, so what we are going to do is we just let's give you a theorem, or let's say that we want to show that. So one can show that, if you like, one can show that. Okay, can show that the curvature. Okay, the curvature of a circle. Of radius r. Radius r is simply the curvature is going to be 1 over r, as I talk about it. It's not that difficult to show. If you have a circle, parametric equation of a circle is what? So note that, okay, so suppose, if you like, suppose the equation of a circle, you know that you go around the circle, the coordinate are cosine t, sine t. So it's going to be, let's say, r cosine of t. That's a one component. So that's the x component of a circle, and r sine of t is going to be the other component. Okay, you know that the equation of a circle centered at 0 with a radius of, with the radius r is x squared plus y squared to the r squared. And this is going to be the x and the y coordinate on the unit circle, or on the circle. Okay, and if you would like to have it make it into the three-dimensional, so this is 0 times k. And then you pick this t to be between 0 and 2 pi. Okay, so that's r of t. Just suppose this is a circle. Okay, it's going to be a circle. It's going to be a circle with radius r. If this is going to be the case, then find those components that we need. Remember, we need the R prime, R double prime. So if you find the R prime of T, with respect to the T, of course, so that gives a negative R sine of T times I. Okay, and that would give us R cosine of T times J. Okay, if you get the norm of the R prime of T, so the norm would be simply what? Negative R sine of T squared plus R cosine of T squared, which is going to be simply, this is going to be R squared sine squared of the T and the R squared cosine square of the T. And if you factor out the R squared, so R squared times cosine squared plus sine squared, so that gives us simply radical R squared, which is equal to the R. So the norm of the R prime of T is simply equal to the radius, which is R. Okay. And then you can find the R double prime and just go ahead, get those numbers. Okay. So R double prime of T, you differentiate this one, so that gives you negative R cosine of T times I, and that would be minus R sine of T times J. Okay. So because the derivative of a cosine is there, right? Yes, that's a R prime, so that give me negative R cosine of the T, and derivative of a cosine would be negative sine, so that give me R okay, times J, so that would be times J. So if you get those cross product and get the result, so it's going to be R prime of T cross R double prime of T. There is another way to do it. I just wanted to show one method. It's IJK. So in the case of the R prime, you have a negative R sine of T. Your J is R cosine of T, and this is 0, of course. When you differentiate it, that gives you negative R cosine of T, and that gives you negative R sine of T and the 0. Okay, get that cross product to get the result. The determinant is going to be, you eliminate the first row slash column, so you get some nothing out of here. That gives you 0 minus 0. Okay, minus J times. This is the J. Again, you get nothing, 0 minus 0. And in the case of the K, this is where you're going to get something. So you multiply these two together, that give you R squared sine squared of T plus R squared cosine square of T. Okay, so everything would be 0 except this last one. Okay, you factor out the R squared. So sine squared cosine squared would be 1. So eventually if you get K R squared or R squared times K. Okay, so that would be the cross product. If you take the norm, so the norm of the R prime of T cross R double prime of T, the norm would be just R squared. Okay, so you can easily get the curvature now. So the curvature is going to be, the top would be R squared, the bottom one we already find it. You see that was R, so that would be R cubed. If you simplify it, that gives 1 over R. So the curvature of a circle is going to be the reciprocal of the radius. Okay, just for your information, that's something something natural that you are going to have. Okay, so this is just for your information. So what I'm going to do is I just explain that circle for you that you're going to have, okay? Just to give you an idea in case in future see it, otherwise we are done with this. There are a couple of other formulas for special cases. If you have a function of one variable, this can be simplified, but we don't need it really, so we are not going to spend time on those. Any question? I post that software. Did you try those? The one that I post on the canvas, is it working? Quadratic surfaces. Anybody try it? The one that I post. You need to have those application to get it. I don't know whether you get it or not, but I'm going to show you another one. The actual one. Let me just bring. This is the circle that I'm going to talk about it. Okay, let me see if I get it. Okay, this is again the application that I talked about the other day. I don't know whether it's going to be working or not. Let's try. You see, this is the one that we call it osculating circles. Can you see it, the one that I'm showing you, the circle? You see, that's going to be the one. So the way they do it, you're just going along the curve, and at any point, you can find the curvature by looking at this circle. And if you have the circle, you know that the reciprocal of the radius would be the curvature. So this this circle is going to be called osculating circles or kissing circles, if you like. So there is a formula for you see, these are going to be the gain that we're going to show you. So I'm going to give you the radius of the circle is going to be the reciprocal of the curvature. And if you want to find the center is going to be on the just like a normal line, which is going to be perpendicular to the tangent line. Okay. So I'm going to go back and give you the equation of this circle just for information. We are not going to use it, and we are not going to question you on that. But you need to know the formula for the curvature only. Okay. So let me just go back and give you a description of this circle to finish it. Then we can go to our practice. Okay. So we know what would happen to the circle. So for the rest, we are going to look at they call it circle of curvature. Okay, so what's going to be circle of curvature? Okay, circle of curvature. Another name for it is like the one that you saw. Okay, oscillation, okay, I think, or oscillating circle, or kissing circle, different names for it. Okay, so what's going to be this one? It is if, just give a description of this circle. If the curvature, okay, if this curvature of a smooth curve, a smooth means R of t is differentiable and it's never zero. Smooth curve C is a non-zero number. Okay, non-zero number. Then each point, okay, each point P on the curve on C can be associated with a circle, can be associated with a circle that is going to be called that kissing circle or actuating circle. Okay, so with the circle called acceleration circle of C at P, of the curve C at P. So at any point, if you go around, travel along the road, freeway, if you want to find your curvature, you have to look at that circle. Okay, so it's going to be called, or sometimes they call it, or the circle of the curvature. In your book, they call it the circle of the circle of the, okay, of the curvature of C. Okay, this is it. This is as I talk about it again. This is it. So at any point P, so if this is going to be the P, you consider this, this is going to be the circle. You just move on, and at any point you can, you can get your curvature. So what is going to be the situation we're going to have? We would like you to give us the equation of a circle. This is how we are going to get the equation of a circle. You see, that's if you consider the curve, you see this is going to be your curve. This is going to be the curve C. Okay. And this is going to be the point P that you are going to be interested in. So what you can do to get it like in a circle, you see, you can have you consider the tangent line here. You see, this is going to be, you see, this is the circle that you're going to consider. So the curvature at the point P, if you want to find it, which is going to be the same as the curvature of a circle, but at this point, you are going to have a tangent line. This tangent line would be tangent to the curve, and it's going to be tangent to the circle. If it's going to be tangent to the circle, you need to find the center of a circle. Now we're going to find the center of a circle. You see, if this is going to be the center of the circle, so your center is going to be on this line. Okay, it's going to be this line. This line is going to be a normal line. You see, N of T. So this line is going to be the line that is going to be in the direction of the normal line, and that would pass through the center of the that oscillating circle to be able to do it. So I'm going to describe it, and I give you one example. It's not bad to see it really. Okay, so note that the circle of curvature, has the following properties. What's going to be the properties? The first one, it contains, of course, the point P. It contains the point P because you have to circle at the P. This is the point that you are interested to find the measure of the curvature. Second one, the radius of this. The radius. Okay, the radius of the circle. You know that the radius is going to be what? Is the opposite of the curvature. They usually denote this one by a special notation. Notation is rho. Rho is going to be equal to the 1 over k. So you know that the radius and the curvature are opposite of each other. Okay, so the radius of a circle, this is going to be the case. Rho equal to the 1 over k is just the radius of curvature. And then this circle and the curve would have the same curvatures. So the circle and the curve. And the curve, okay, have the same curvature. We do have the curvature of a circle, so that curvature of a circle would be curvature of the graph. Now the big one is this one, center. How are we going to find the center of that? The center of the circle, as I show you, lies on a line in the direction of a normal line. Direction of unit normal vector, to the curve C at the point P, exactly as I show you. That's going to be the case. So, you write the equation of the line, you know that the equation of the line is going to be, you need the point has a t0, and you need that direction, which is going to be the case that you have. So if you want it, I give you the center. Any question on this one? I give you one example, you will see it. It's not easy to find. Sometimes it takes times, but it's nice to know from the geometry point of view. Okay, so move the page up, sorry. That is going to be the case. Okay, so let's give you the center and I'll show you one. If you have done a differential equation, when you combine it with the curvature, that give you some very interesting problem. And this is the way they do it. If you want, you see, when you want to design a road, so you determine the curvature in advance yourself. You see, we get two different types. So you determine the curvature first, then you are going to design the path. Remember, the curvature involves those the first derivative and the second derivative of your function. So if the curvature is given to you, the result going to be a differential equation. Then you have to solve that differential equation to be okay. Okay, so this is number 4. Can you see now? So that equation, that differential equation, is very popular. If you search on internet, you see some very famous equation. When you want to design, most of them, you can use different devices to solve it. So that would be quite interesting problem, but not for, in this course, we just introduce those terms. But it's going to be very much involved. Are you done? There is a great French mathematician or American mathematician now. He's in USC, and he's a very good lecturer. I've been a speaker. He's very much an expert on curvatures. So I've been to several of his talks. So he got different possibilities, different cases. That's why I explained this one a little bit, in case in future you'll be interested in, or you get involved. Okay, so I finish it by giving you the center of that curve. So the center, it's going to be on that normal line. The center is the terminal point. Okay, it's going to be the terminal point of the position function, of the position vector. This is going to be the position vector they're going to have, you see. Your position vector is going to be this one, if you call it L of t. Remember, it's a point R of t0 plus you get that rho, which is going to be the radius 1 over k times n of t0. You see, that is kind of when you write it down. So this would be this is going to be the position function. It would have the initial point. You see, the initial point would be at t equal to the t0, and this vector would have an terminal point, if you like. Depends on the t that would be given to you. Then that would enable you to find that center. Okay, so it gets very much involved. I have one example. Let's see if I can do it. It takes quite a while to be able to do it. I may post it for you, in case you are interested in get that example, because I want to go on the practice quiz. That would be the description that we're going to have. Even if you take a very easy one, it takes times to be able to do it. Okay, this is that example. You see, the function is even y equal to sine x, very easy function, but it gets quite much involved to be able to go through all those procedures that we're going to have. Okay, so I will only end up with one special case that you may use the curvature of a function on the plane, and then finish it. Okay, so we end up with only this theorem, because in application all the time you just have a function of one variable. So what's going to be the curvature? Curvature of a graph, function type of calculus 1, of a graph in the plane. Okay, and the graph is y equal to the f of x. We can use that formula, but it would be easier to use this form, especially case. So it can be proved that the curvature the curvature of the curvature, let's say, of the graph y equal to the f of x at the point x comma f of x in two-dimensional is given by, this is the type that we use in differential equation. K of x is equal to the absolute value of f double prime of x divided by 1 plus f prime of x squared, everything to the 3 half. If you want to use the assignment, solve your assignment, use this one. The one that you have on the test is a vector values function, so you'll be fine. You just use that formula, but this is for you if you want to use solve some of the problem in your book. It can be done with that format to show you, you see. If you want to see the proof, see, you have to change this one into the vector valued function. So easy to change to the vector valued function. We usually go with R of t. You can change, keep this variable as x, you see. This is it, the curve y equal to the f of x in parametric form, in parametric form is this one. So look at this one, R of x, You change the parametric form. We have x and y, x and f of x. That's it. Which is xi plus f of x, j. That's it. Or if you like three-dimensional, r of x is what? X, f of x, and 0. That's it. So find the curvature. You know, in general, if it's given to you, you can do it yourself. But if you want to get that formula, so that's it. Find the r prime, which is going to be 1, f prime of x, 0. Find the r double prime, which is going to be 0, f double prime of x, 0. Find the cross product, r prime of x cross r double prime of x. Determinant of this matrix, I, j, k, 1, f prime of x, 0, 0, f double prime of x, 0. You know that we can extend it on the last row. So we extend it, you get the 0, 0, you know, I just give you the result. So it's going to be I times 0 minus j times 0. We get only k times f double prime of x, because you know those two zeros that you have. Okay. So r prime of x cross r double prime of x is simply f double prime of x times z by k. So the norm square, norm of the r prime of x cross r double prime of x is going to be what? Is the f double prime of x all squared. Everything else is 0 plus 0. And this would be absolute value of f double prime. You know that you have to put the absolute value because you don't know whether f double prime is positive or is it going to be negative. So that's the top 10 for the curvature formula. And you need the norm of the r prime, norm of r prime of x. And this is your r prime. So the norm is going to be the square root of 1 squared plus f prime of x squared plus 0. So that gives simply 1 plus f prime of x all squared. That's it. If you divide the first one by the second one as we have it, we get your formula right away. Okay, remember the formula for the curvature was we get the top one divided by the norm of the r prime of x cubed. So the top would be the absolute value of f double prime of x. The bottom one would be this one cubed, which is, you know, we change it to the 3/2. So I put it over here. Okay, so the curvature formula for this type of function is going to be absolute value of f double prime of x on the top, and on the bottom 1 plus f prime of x all squared, but to the 3/2. This is a classic formula. If you are not going to be in calculus 3, they use this formula for the, okay, for the finding the curvature of a plane curve, we say. So this method will tell you that it's not a big deal, you can find it yourself if you don't know the formula. But on the quiz, on the test, you are not going to have this type of function. So, you can write it down and take it with you to the test, but you don't need it. I'll just give you one example and then we're done. This is the one that I just write it down so that you can see the differential equation type. You see, if you have that course, they say, oh, find a curve whose curvature is 1/2, for example. If you want to find a curve whose curvature is 1/2, you have to put k equal to the 1/2, solve for f of x. You know that if you cross multiply, that gives you a differential equation. And that differential equation is not going to be easy all the time. So this is the way they use it in application problems. They use this formula for the classic case. Okay, just give one example and we finish it right away. Question? So that give you the something in applications, although you're not going to see it anymore, but it's nice to know it mathematically. So this is the example. Find the curvature of a classic function. Find the curvature of this function, of the graph of f of x equal to x cubed. The one I didn't do here for the accelerating curve, my function was sine x. That's why I didn't do it at that time. That's it. It's a classic function and you have the formula. So you need to find the first derivative, second derivative. Okay, solution. Find the f prime, 3x squared. Find the f double prime, 6x. Formula for the curvature, k of x equal to absolute value of f double prime of x divided by 1 plus f prime of x, everything is squared to the 3/2. Just substitute and then you're done. K of x is equal to absolute value of a 6x. The bottom one would be 1 plus 3x squared, all squared. Then do the 3/2. The only thing that you can do is this. K of x is equal to the absolute value of a 6x. The bottom one would be 1 plus 3 squared would be 9, x to the 4th, everything to the 3/2. That is going to be the curvature. When it's of this form, of course, they are not done. They ask you to minimize it. To minimize it, this is a function, in calculus 1. You differentiate it, you let it equal to the 0. You find the critical values, and then you estimate it. Okay, so that's it. That's all we need from altogether from this chapter. So we're done with the vector valued function. As I talk about it, we are going to see 3 types of vector functions in this course. This is the first one. So when you are done with your test, we come back and we start it over. We are going to have a function whose domain is going to be kind of vector. Domain is going to be points in 2-dimensional or points in 3-dimensional. So that gives us a function of 2 variables and the function of 3 variables. But the range is the real numbers. So it's a real valued function of 2 or 3 variables. We started over the domain, the limit, continuity, differentiability, and the integrability. That's what we got. Okay, so we can have a break now. We come back, I'll go over that practice test for you. I explained a couple of problems to see how we're going to handle it for our test. Okay, that's it. See you in about 10 minutes. Okay. Okay, I checked that, extra one, I posted on a wrong place. After the class, I will I will repost it on on the proper place for you. I check both of them. Okay, so there you are. The test, 11 questions would be given to you. Okay, it's going to be 5 from the quiz, the one that you did. Okay, more or less the same. You just knowing, that the formulas for writing the equation of the line planes, compare them together. So it would be repeated, and the second part, the 6, a new one, are going to be mostly regarding this new function that we talk about it. Okay, so I'm going to explain some of those function parts because the first part's easy and you already got the solution. So I go with question number 7. Okay, so on the first part, that the equation of cross product, dot product, those triple one, idea of the finding the area, the volume, these are going to be the one that it can be done easily. So let's do the new part. So that would be practice test number 1. So we go with the function part. Let's start with number 7. A vector valued function would be given. Of course, we ask for the domain of the function. Okay, so that's going to be the first topics that we have to know. So in number 7, find the domain. Find the domain of each function. Let's miss maybe it's going to be vector valued function. Okay, so the functions are going to be just the first part. I just want to make sure I have the correct one on my my notes over here. It starts with the t to the 8. Yes. So the first function, part 1, the function is r of t equal to the t to the 8. Okay, the square root of t minus 1 and the 9 minus t. You have to get the domain of the component function and then get the common part, if you like. Okay, so the first function is going to be, this is it. So x of t is equal to the t to the 8. You can do it right away. This is the way I write it down. This is defined everywhere. Okay, the second one, y of t equal to the radical t minus 1. You know that this is defined where t minus 1 is greater than or equal to the 0. So t must be greater than or equal to the 1. So the domain is going to be 1 and positive infinity. And the third one, z of t equal to the radical 9 minus t. So 9 minus t must be greater than or equal to the 0. So that would imply that the t must be less than or equal to the 9. So the domain of the third one is going to be negative infinity up to the 9. Okay, so you compare them together. This is going to be negative infinity to positive infinity. You can forget about this one and compare the other two. So this is going to be 1 and positive infinity. Okay, and you have a negative infinity. So that would be negative infinity up to the 9. Up to the 9. So as you can see, the common part is going to be between 1 and 9. So the domain of the function is going to be 1 and 9, which is going to be intersection of those three. Okay, any question? So, just give us the domain we accepted. So this is going to be one of them is going to be 7. Okay, that's a number 7. It's just one part. You have a similar one in terms of the 8. So in 8, the function is given to you. So you have r of t. Okay, r of t is equal to the radical 2 minus t, comma e to the t minus 1 divided by t, and that get ln of t plus 1. Is a little bit more involved. They ask a couple of questions over here. The first part, they ask for the domain of the function. Domain of the function, same thing. So again, x of t is equal to the radical 2 minus t. So 2 minus t must be greater than or equal to the 0. That implies that the t is less than or equal to 2. So the domain is going to be negative infinity and 2. Okay, that's the first part. The second one, y of t equal to the e to the t minus 1 over t. You know that the top exponential function is defined everywhere. The numerator cannot be 0. So t cannot be 0. So the domain of the second one is everything except 0, negative infinity to 0, union with 0 and positive infinity. The third one is ln function, z of t equal to the ln of t plus 1. Restriction is that the t plus 1 must be positive. So t must be greater than or equal to negative 1. So the domain of this part is going to be negative 1 up to the positive infinity. Okay, put them together to get the common domain. Negative infinity to positive infinity. This one is everywhere except 0. So I exclude the 0. The other two, negative infinity to 2, negative infinity to 2. So this is going to be the other one. The last one, a negative 1 to positive infinity. So this is going to be negative 1, negative 1 to positive infinity. Positive infinity. Okay, so the red part blue and the black part. Okay, so what is going to be the common part that we are going to have? You see that first, the blue one is negative 1 to positive infinity. So that's going to be the blue one, the red one. So as you can see, this part is going to be your case. Okay, that's going to have. So your case starts from negative 1 to the 0 and the 0 and 2, because you don't have the 0, so it's not negative 1 and 2. So the domain would be, start with the negative 1, you arrive at the 0, open, union with, you start with the 0, and you end up at 2, close, because you get, you get the solid point here. Any question? So it's going to be involved with, something like ln function, a square root function. This is always the case. Okay, so prepare for the domain. Any question? In this function, they ask a couple of more questions. They ask for the limit of r of t when t goes to 0. So that's part B of this. Okay, are you done? So part B, this is what you need to find of same problem. Part B, they ask for the limit. What is the limit of RT when t goes to 0? So that's a missing part. You know that you take the limit inside. So the limit of R of t goes to 0. You go inside the vectors, the component vectors. So the first one would be the limit of radical 2 minus t when t goes to 0. The second one goes with the limit of e to the t minus 1 over t, t goes to 0. And the last one is the limit of ln of t plus 1 when t goes to 0. Just explain it. You can do it right away. You know that the limit of the function, vector values function, is the limit of the component. So take each one by one. So the limit of the radical 2 minus t, t goes to 0. Direct substitution give you radical 2. So this is the first one. Limit of the second one, limit of e to the t minus 1 over t, t goes to 0. Okay, if you substitute, that give you 1 minus 1 over 0, which is going to be 0, 0. You know that you have to come back and use the Hopital rule or L'Hopital rule, differentiate the top and the bottom, and then substitute again. So we are going to use the L'Hopital rule or the Hopital rule. So it's going to be limit of, we differentiate derivative of e to the t would be just e to the t. Derivative of 1 would be 0. Derivative of t is 1. Now t goes to 0. So it's going to be the limit of e to the t. T goes to 0. So that gives you e to the 0, which is equal to 1. So the limit of a second one is 1. Any question? So be prepared for it. You may have to use the Hopital rule, okay, or the L'Hopital rule. We have one more to go. The third component. So it's a limit of ln of t plus 1. T goes to 0. Direct substitution, because the ln is a continuous function. So that gives you ln of 0 plus 1 would be ln of 1, which is equal to the 0. So the result, radical to 1, 0. So the limit of r of t when t goes to 0 is a vector, radical to 1, 0. That gives you the final answer. Okay, so let's pick one of them. Just do it step by step. That is going to be the case. They ask one more question. They ask for the derivative of the function, which is very easy to find, r prime. So in this problem, they ask for all the question that we need to know. Already, they ask for the r prime of t. You know that you differentiate each component. You can do it one by one, and just do it right away. Okay, so I just do it one by one. So the first component was radical 2 minus t. I change it to the 2 minus t to the half. I use the chain rule. X prime of t is equal to the, you know, that's like u to the 1/2. It's going to be 1/2 of the u to the negative 1/2 times u prime. So it's going to be 1/2 2 minus t to the negative 1/2 times the derivative inside, which is a negative 1. So I rewrite it. X prime of t equal to, you know, different way to write it down. This is one version if you like. So the top would be a negative 1, denominator 2 radical 2 minus t. This is the usual practice to write it down. So that's the derivative of the first component. Any question? Second component, we have to use the quotient rule. So the second component is e to the t minus 1 divided by t. So differentiate quotient rule, derivative of the top, bottom, bottom, top, and simplify. So y prime of t is equal to, derivative of the top one is just e to the t times the bottom function, which is t. minus derivative of the bottom times top. If the bottom one is 1 times top, e to the t minus 1 divided by the bottom square. Okay, I'm just using the quotient rule. So y prime of t is going to be equal to the top, we get t e to the t, apply the negative sign, minus e to the t plus 1 divided by t squared. Can't do anything about it. So that gives you y prime. Okay, so we did the first component. Second component, we have the third one. Third one, ln of 1 plus t. So that would be easy to find. The derivative of ln u prime u. Okay, are you done? So going to the third component, z of t. So the third component, we have a z of t, which is ln of t plus 1. You consider ln u, derivative would be u prime u. So z prime of t, u prime would be 1 over t plus 1. So the final answer, r prime of t is going to be equal to derivative of the first component is a negative 1 over 2 radical 2 minus t. The second component is t e to the t, okay, minus e to the t plus 1 over t squared. And the last one is 1 over t plus 1. Okay, so that gives you derivative of the function. Okay, so in this problem, you just do, all the property of the function that we're going to be interested in. So we are going to give you one to get these numbers. Okay, any question? So your next main question from this section is going to be a function would be given to you, and we ask for the unit tangent vector, which is t of t, and the unit normal vector, which is n of t. Okay, so be prepared for it. Okay, we try to give you something that can be done easily, but otherwise, it's not a big deal. You got to be a little bit patient, especially to get to the n of t. So this would be question number 9. Okay, in question number 9, so you have the function r of t is given to you. R of t is a 1/3 of the t cubed, and that's a 1/2 of the t squared and the t. Okay, sometimes they ask to do it in one specific, okay, for a specific value, but in this case, yes, they ask to find it at t equal to 1, okay, which is good. When the number is given to you, it would be easier. Okay, so what we would like to find is, we would like to find the unit tangent vector, which is going to be t of t. Okay, and the unit normal vector, which is n of t. But they ask you to find it at t equal to, okay, at t equal to 1, which is good. Okay, there you are. You know the formula for the t of t. So we do this one first. Okay, so that would be part 1. Part 1, we know that the t of t is the tangent vector, which is normalized. So the tangent vector is r prime. R prime of t, normalizing means the norm of the r prime of t. Okay, so this is the formula for the unit. You have to know this formula. Unit tangent vector. Tangent vector. Of course, you want to find s t equal to 1. So let's go and find it. We need r prime. Differentiate. So what is going to be r prime? R prime of t, differentiate component 1 by 1. That's easy. 3 times 1/3 would be 1. So we get a t squared. Okay, and that gives you just t, and the derivative of t is 1. So that would be r prime. r prime of t. In this problem, they ask to find it at t equal to 1, so we can evaluate it. That's 1. I talk about it. You see, I said that extra 1 attachment is missing. So this afternoon, when I'm done with the lecture, then I'll check the attachment. The attachment for the extra 1 on the canvas is missing. I probably added to the some wrong place because I have it myself. I do it. I fix it for you after the lecture. Okay. I fix that one. I just check it and I find out that you are right. This is it. I may fix it, add it to the other course that I have. Okay, let's continue. You see, you wanted at t equal to 1. Since you want at t equal to 1, you can find the r prime of 1 here first, then continue. That's easier. Or you can go on and do it later. It would be better to do it now. Okay, so I have the t equal to 1. So I find the r prime of 1, and from now on, I stay with the single vector. So you replace t by 1, that give me 1, 1, 1. You see, that's r prime of 1. Then I need to find the norm of this vector. Norm of the r prime of 1 is simply what? The square root of the square of the component is all 1. 1 is squared, 1 is squared, 1 is squared. Give me all ones, which is going to be radical 3. You see? So since I wanted add 1, so I find t of 1. T of 1 is r prime of 1 over the norm of the r prime of 1. Okay, I substitute for the r prime first, which is a radical 3. So that gives me r prime of 1 over radical 3. So this would be 1 over radical 3, the vector. Okay, 1 over radical 3, the vector. Vector is 1, 1, 1. You have to take the 1 radical 3 inside. So t of 1 is equal to 1 over radical 3, 1 over radical 3, and 1 over radical 3. That would be the final answer. You cannot leave it here as is. This is not a vector. This is, it is a vector, but it's a multiplication of a scalar. You say a scalar times the vector. So the vector form is this. You have to do it. Okay, any question? So if the number is given to you, just take it right away. You can form this one first, again, then substitute the number. Is up to you. But this is easier. That's the first part. Unit tangent vector. Any question? Your challenging is this one. Okay, it takes time. Be patient to be able to find it. Okay, and there is going to be one. The easiest one is a helix, but it's not bad, but be ready for it. Okay, so we go with the B, and we are interested in n of t. Remember the normal vector. This is unit normal vector. Normal is t prime. Remember, t prime is perpendicular to the t of t. So the normal is t prime of t, but you have to normalize it. So to normalize it, you have to divide it by the norm of the t prime of t. So make sure you have a correct formula. That's why you have to go back. You have to form the t of t because you want to differentiate. T of t differentiated. When we get to the t prime, then you can substitute t equal to 1. Okay, so let's go back and just find the t prime. So we just remind ourselves, because we did it at 1 here. So we remind ourselves that the r prime of t, okay, from the other part, or you just find it again if it's going to be different. So r prime of t is what? Is a t squared, because you have to find the t of t first. T and 1. Okay, that's going to be r prime. You have to find the norm of the r prime of t. Norm of the r prime of t. The norm would be, it's going to be the square of this component. So that gives you t to the 4th. okay, t squared and 1. Okay, so I'm going to bring the t of t. So my t of t is going to be r prime of t over the norm of the r prime of t. So we're going to substitute. Okay, if you substitute, the vector is t squared. Okay, t1, that's a vector. And the scalar part is this one, t to the fourth, t squared plus 1. Okay, so this is going to be your case. Now you have a different version to apply this one. You can take it inside if you like, because you have to differentiate it. Or you can keep it as is. Okay, this is going to be up to you to talk about it. So the way I did it, I just moved this one up. I write it down as a t to the fourth. In both cases, you are going to do this one. Okay, this is going to be negative half. And I multiply by this vector, which is going to be t squared, t and 1. You want to differentiate. If you keep it as is, it's better because you're just using the product rule. Derivative of the first times second, second first. If you take it inside, that's fine. But you have to do the product rule 3 times. Okay, so I keep it as is, and you decide which one you want to do. But it is going to be the case. So I'm going to use the product rule here. That's easier to apply it. Okay, so let's apply the product rule to find the t prime, because you need the t prime to get the normal and then normalize it. Okay, let's do it. Derivative of the first times second. So the first one, we have to use the chain rule. Okay, it's like u to the negative 1/2, so it's going to be negative 1/2 t to the fourth plus t squared plus 1 to the 1 dot. Negative 1/2 minus 1 would be negative 3/2 times u prime. U prime derivative of the inside, which is 4t cubed plus 2t. This is derivative of the first one, okay, which is all scalars. Is going to be derivative of the first times second. Second is a vector, it's a times it by t squared, a t and 1. Okay, that's derivative of the first times second. Now it's going to be plus derivative of a second times first, which is easy, plus derivative of a second one is just a vector. Times it the first one, I write it down in this form, is going to be t to the fourth, t squared plus 1 to the negative 1/2. Now times it by derivative of a second, which is a 2t, 1 and 0. You see, this is going to be t prime of t. Question? Now, since I wanted, they usually give you a number, otherwise, it would be quite a lot to operate to find the norm. Since they ask it as t equal to 1, they ask for the normal vector at 1, I'm going to put t equal to 1, then I continue. Otherwise, it takes quite a while to be able to do it. It would be almost sometimes impossible. Okay, so what I'm going to do, I'm going to get it at 1 first, then I continue. So replace t by 1. Can be easily seen what is going to be the result, but be careful. Then you have to simplify. It's going to be t prime of 1 equal to, put 1, so that give you negative 1/2. Is a 1, 1, 1, that give you 3 to the negative 3/2. Oh, sorry, times it by, if you put the 1 here, carefully, that give you 4 and 2, which is going to be 6. Okay, times it by 6. Then times it by a vector, 1, 1, 1. Then continue, bring it here. With 1, that give you 3 to the negative 1/2. Times it by the vector, which is going to be 2, 1, 0. Okay. You have to simplify it more to be able to handle it. So that's going to be the 6, 6 and 2. I simplify these two first. Okay, I simplify this 2. So that give me, just make sure I didn't miss anything. I did get the 6. I get the 6 from here, yes. So that would be 3. So I'm going to have, I rewrite it, then I simplify it. So I have a negative 3 to the negative 3 half. Okay, times it another 3 here. Then I have the vector 1, 1, 1. Then over here, the same thing, 3 to the negative half. Then I have the 2, 1, and 0. Okay, any question? This is 3 to the first power, and this is 3 to the negative 3 point, okay, it's going to be 3 half. So it's a negative 1.5, and the positive 1, that gives negative half. So that would be 3 to the negative half, then you'll be able to simplify it and put them together nicely, okay? So these two together, if you multiply them together, that give you 3 to the negative 1 half. I'm going to explain it. Any question? Are you done? So going to the next page and continue. I'm going to check this one first. Then I switch it. These are vectors. Then we add the vector together. That gives the prime of 1. And then we find the norm. We normalize it. And that gives us the normal vector. Okay. So this is it. Continue one more step to simplify it. So I repeat it that I'm going to have a t prime of 1. So as I talk about it, the first one would be changed into the negative 3 to the, okay, 3 to the negative half. I have the vector. The vector is 1, 1, 1. And the other part, I did have a 3 to the negative 1 half. And the vector is 2, 1, 0. That's it. Now I can add them together. Okay, I can change this into the fraction radical form. Maybe that would be easier. And this is going to be 1 over radical 3. And this is going to be 2, 1, 0. Add these vectors. So what's going to be t prime of 1? Okay, I add them together. I can factor out the 1 over radical 3 and do it, or just do it right away. It doesn't matter really. So this is it. It's going to be, the first component is going to be negative 1 over radical 3 of the first one. And the second one, you have 2 over radical 3. Okay, switch this. So that's my first component. The second component, I have a negative 1 over radical 3 from this. And over here, I have 1 over radical 3. The third component, I have a negative 1 over radical 3 from the first part. And the second part, I have 0. Okay, so this two would cancel out. So t prime of 1 is going to be the 2 minus 1, which is going to be 1. 1 over radical 3. I get the 0. And I have a negative 1 over radical 3. So this is going to be the normal vector, t prime of 1. Any question? You have to normalize it, find the norm, and then divide it. That gives you your normal vector. Okay, find the norm. Norm of the t prime of 1. You know that the norm is going to be the square root of the square of the component. 1 over radical 3 squared. That would be 0. And then 1 or negative 1 over root 3 all squared. So this is going to be 19, 0 plus, okay, 1/3, sorry. 1/3, radical 3 squared would be 3. And that would be 1/3. Okay, 1/3 and the 1/3 would be 2/3. So I put the radical on the top and the bottom, so that give me radical 2 over radical 3. Because I can simplify it, in a minute. So that would be the norm. So the normal vector at 1 is going to be uninormal vector. That's going to be t prime of 1 over the norm of the t prime of 1. just substitute. So it's going to be t prime of 1. This is t prime of 1. Okay. So it is the vector 1 over radical 3, 0, negative 1 over radical 3. And the number over here is going to be radical 2 over radical 3. So we can divide it with the component. Those radical 3 would be cancelled out. Okay, if you like a different way to simplify it, you can pull out the 1 radical 3. So that gives you 1, 0, negative 1. And over here is just a radical 2 over radical 3. So the radical 3 would cancel out. Okay. So the final answer, the normal vector, is going to be the top. That's a vector. On the top, we get 1, 0, negative 1. And on the bottom, we get the radical 2. So the normal vector is 1 over radical 2, 0, and the negative 1 over radical 2. That gives you the normal vector. As you can see, it takes times and you have no shortcut, just be patient. We try to give you something that can be done easily. If you don't see any number, okay, that would probably involve some sine and a cosine, and that probably can be simplified right away. But if you see the number and no sine, no cosine, be patient. You have to go through it to get, to get that final part. Okay. Can you go back to where we did the quotient rule? That is where we did the quotient rule. Okay, so let me just see what you want. You see that is, see the way I did it? You see, I didn't use the quotient rule. I moved this one up here. Okay, I change it to the product. That's much easier. You're gonna stay with this one, but good luck, because you have to use the quotient rule for each of those components. So the quickest way to do it really is you move it up and use the product rule all the time, okay? The product rule would be easier, derivative of the first times second, second first. And since it's the numbers involved, okay, you just simplify the numbers, quickly. That's much better. Don't try that quotient rule. Okay. So be prepared for it. One question, finding the t of t and n of t. You need tangent vector and the normal vector. This is part of the game that would be given to you. Okay, any question? And the vectors, since they are both. Yeah, we can do the product. Yeah, yes, you're right. Yeah, you're right, Danny. It's just a scalar function and the other one is a vector. And we already talked about it. Okay, so this is one format. The other format of these problems for the tangent line, remember we talked about it, we can find the parametric equation of a tangent line. So make sure you know it, how to do it. That's easy. We need it for future. That's why your book, they didn't focus on this one, but we do. Vector equation, remember vector equation of a, so this must be, yes, it's a problem number 10. So problem number 10, make sure you know what we are asking for. Okay, so we are asking for what? Vector equation. Okay, vector equation, parametric equation. Vector equation of a tangent line. Okay, and that is going to be the case. So the parametric equation, we talk about it, is like everything else. It's like the calculus 1. You need the point and the slope. So this is the equation, parametric equation. Is like, the function y equal to the point at t0. Okay, and then it's going to be the slope is a directional vector. Directional vector is the derivative. You see, that's what we get the vector equation of a tangent line. Okay, you need a point and the slope. This is the point because the equation of the vector valued function is going to be a vector function. Instead of the slope, we just use the directional vector. Directional vector, of course, is the derivative. That's it. So a point and the vector are given to you. They've been asked to find it. So in this problem, part one, r of t is given to you. Okay, r of t is 2t minus 1i plus the square root of 3t plus 4, j at the point P equal to, it's in two-dimensional, it's a plane curve. You have one in two-dimensional, I think, and one in three-dimensional. Okay, so be ready for both of them. That's it. The thing that you have to do, because you are going to use the, okay, you are going to use the T0. So you have to identify the T0 corresponds to the -1 and 1/2. Okay, so that would be your first job. So the first job is going to be r of when r of t is going to be equal to the vector form of a -1 and 2. So you have to find this t, if you like. That t would be your T0. Okay, so you're going to compare it with your the component of your function. So the first component must be the same. So you want to find the t, so that 2t minus 1, 2, you can guess, but I just write it down. And this is the second component, is at 3t plus 4 to be equal to 2. Okay, you get it from the first part, and that give you 2t is equal to the 0. So t must be 0. Okay, you check it to make sure that it's correct. So you check it here. If you put the t equal to the 0, so that give a radical 4 equal to 2, which is correct. So your T0 is 0, because you want to use this formula. Any question? So that's it. So we got the fact that r of T0, which is going to be equal to that -2 and 2 that we have. Okay, there's going to be T0. So r of T0, which is over r of 0, and we know that it's going to be -1 and 2. So we have to find the r prime. Okay, so differentiate r prime of t. You know that you differentiate each component one by one. So it's going to be the first one, you differentiate this one with respect to the t, that give you 2i. And the second one, you want to, that's write down as a 3t plus 4 to the 1/2. So that's going to be 1/2. 3t plus 4, okay, to the -1/2 times u prime, which is 3 times that by j. I just use the chain rule. Okay, so r prime of t, in component form, if you like, this is going to be 2. And this is going to be, this is it, 3 on the top, 2 radical 3t plus 4. Okay, in component form. Any question? I just used the chain rule for this one. So you find it at the 0. R prime of 0 is going to be 2. And this is going to be simply what? It's going to be 3, 2, radical 0 plus 4, which is going to be 4. So that give you 2, 3. 2 times 2 would be 4. So that's a kind of the slope or the directional vector. So r prime of 0 is 2, 3/4. So that would be your directional vector, and you have the point, you go back and you write the equation of the parametric equation of a tangent line. Okay, so remember L of t is going to be R of 0 plus t times R prime of 0. So R of 0 is that point is making to the vector -1 and 2 plus t times 2 and 3/4. That's it in a parametric form. If you like, L of t is going to be equal to component. The first component would be -1 plus 2t. And the second component would be 2 plus 3/4 of t. So this would be a parametric equation of your gear. We're going to use this type of ideas in chapter 15. When we go to the line integral, we do quite a lot of this type of ideas. So we just want to make sure you're ready for it. Okay, that's in the two-dimensional. You have one in three-dimensional. I can quickly explain that one too, because these are the ones that are easy, but it's going to be used. So we give one question on this, okay? Be aware because we are going to use it. So that's it. That was a part one, if you like, of this problem. So let's do the part B quickly so that we keep them for future. So that would be 10B, if you like. Your function is going to be in three-dimensional. Okay, so R of t is t square I minus 1 over t plus 1j. Okay, plus 4 minus t squared k. And you want to do it at the point p equal to the 4, 1, and 0. Okay, the same thing. You have to find the corresponding t. You can compare them to get it. You see, if you compare it, the first one, t squared is equal to 4, so t must be 2. So we can check it. Let me check. So the first thing to check is to find the value of the t. So you want to find the value of the t so that this would be equal to the 4, 1, and 0. Okay. If you compare them together, so the conclusion is going to be the first component, the t squared must be 4. Okay, in the second one, -1 over 1 plus t must be equal to 1. And in the last one, 4 minus t squared must be equal to the 0. So you solve one of them and you check it in the others. These two are going to be the same. Okay. So, from this one, if you like, you get t equal to the positive -2. And you have to check to see if this is going to be true for this one. And this would be 1 plus t equal to the -1. So t would be -2. So this means you are going to pick t equal to the -2. Okay, it must be a common solution, if you like. A common solution. You see, that would be t positive -2 as well. So if you pick the -2, it satisfies for all of them. So the t0 is a -2. Any question? So you have to find the corresponding values. Now your equation L of t is going to be R of -2 plus t times R prime of -2. So your R function, you differentiate it if you want to rewrite it in component form. So you have the t squared, you have a -1 over t plus 1, and you have the 4 minus t squared. This is your t function, R function. Differentiate to find the directional vector or the slope, or the corresponding to the slope, okay? So differentiate R prime of t, and that give you 2t. Over here, you can use, a kind of quotient rule where you bring it up. The lift of the top times bottom would be 0. Bottom top would be 1. This negative would disappear. So that gives you 1 over t plus 1 all squared. That's the lift of the middle one, and this is going to be -2t. Okay, so I differentiate t squared to t. Differentiate this one, you can move it up, t plus 1 to the negative 1 quickly, or just the top bottom derivative of the top would be 0. The bottom is 1. There is a negative sign here, make it a positive. Now we have to find it at negative 2. So what's going to be r prime of negative 2? So we substitute 2 times negative 2, and this is going to be 1, 2 plus 1 all squared, and the negative 2 times 2. Okay, simplify to get the directional vector. So r prime of negative 2 is going to be negative 4. That gives you 3. 3 squared, that would be, okay, 3 squared would be, did I miss anything? Yes, that's a negative 2. So that must be negative. Okay, now negative 2 plus 1 would be negative 1. Negative 1 squared would be 1. So that give me 1. And that give me, and this is a negative 2 as well, okay? Remember, it's a negative 2, negative 2, negative 2, negative 2. So that makes the last one into 4. That's it. That's a directional vector. Any question? We are ready to give you the equation of the line. So that's it. Remember R of L of t. That the equation is R of 2 plus at the negative 2 plus t times R prime of the negative 2. Substitute R of negative 2 is the given point, 4, 1, 0, plus t times negative 4, 1, and 4. Get it in component form. So L of t is going to be equal to, that give a 4 minus 4t. That's the first component. The second component, 1 plus t. And the third component, this is going to be 0 plus 4t. So the equation L of t is going to be 4 minus 4t, 1 plus t, and the 4t. So that gives you the parametric equation of your tangent line, and then be done. Okay. Any question? So this is going to be the case that we're going to have. So that's one. The other problem are going to be related to the finding acceleration, okay, velocity, position function. So we have a couple of them over here. I'm going to quickly explain the one that you have to do something to the speed. Okay, so this is going to be, should be number 16. Yeah, we didn't do anything like this one. So I'm going to explain this one. The other one are easy. Okay, so we give you a couple of questions on the relationship between the position function, velocity, and acceleration. You know that. If you differentiate a position function, that give you the velocity function, and differentiate again, that give acceleration. But if you want to find the speed, you have to find the norm of the r prime of t. Okay, so this is number 16. There is something extra that you have to do. You have a couple of them in your book, and we are very much interested in. So we are going to be interested in this part that we want to find the maximum speed. Okay, so what is the maximum? I do in that part, speed. Okay, maximum speed of the moving object with this equation. R of t equal to 7t squared. You quite a lot in your book. 7t. There is algebra involved. I want to make sure you know it. 7t squared minus 140t. Okay, so that's a moving object. They usually ask for the velocity. Okay, and then they ask you when the speed is going to be a maximum. You see, that's a question. So We have to go for the speed first. Okay, so the solution is going to be, remember the speed. This is it. A speed S of t. Okay, a speed or the speed function is the norm of the r prime of t. Okay, so that's a kind of a speed or the speed, a speed function. It's a scalar function, so you can do whatever you like with this. So we have to find it. We go for the r prime of t first, differentiate 14t, 7, 14t minus 140. Carefully differentiate. That's r prime. You know that this is velocity. This is going to be velocity. So you get the norm of the velocity that takes you to the speed. So find the norm of the r prime of t is going to be the square root of 14t squared, 7 squared, 14t minus 140 all squared. Carefully square it. Any questions? So we must do the formula. That's your formula for the speed. So square it to see what would happen. 14 squared. 14 squared would do 196 t squared. 7 squared 49. Carefully square this one. The square of the binomial, the square of the first, twice of the first times second, plus the square of the third one. Some people, they miss this one. Okay, square of the first term is 196 t squared, 2 times first times second. You see, 2 times first times second. 2 times 14, 28, 28 times 140. That give you 3,920. That's it. T. That's the twice of the first times second. Plus the square of the third one, 140 square is 196, 2 zeros. Okay, any question? Most of the people, they miss this one. Then you'll be in trouble, okay? It's the square of the binomial 3 times, 1, 2, 3. Combine the like terms. There is going to be a situation that you simplify these two together and you simplify these two numbers. So r prime of t is going to be, okay, that's it. If you add these two together, you twice it, you get 392t squared. Okay, then we get 3,920t, and the constant term 49, and that number give you 196.49. You see, this is going to be a speed function. So the speed function, or the speed. Okay, the speed function is going to be 392t squared minus 3,990t plus, okay, this is the speed function. The speed function. That's it. Now you see, you want to find the value of x. You see, that's what you want. Find the value of t where s of t is a maximum. This is your job. You want to find the maximum value of this, okay? Maximum value of this function. Okay? So yeah, you can simplify, but we don't care. Just wait for the minute. You will see it. Okay? So you want to find the maximum for which value of the t, this is going to be a maximum. You know that it's a scalar value function. You have to differentiate it. You differentiate it, you let derivative equal to 0, you find the critical values, and then you get it. But you can use a shortcut. The shortcut is going to be, you see, we are interested in the which value of x make this one a maximum. So instead of considering the s of t, you can consider s of t squared. because the maximum value would be different, not the value of the t. Okay, so the way you're going to do it, you want to find the value of the t so that this s is going to be a maximum or a minimum. In this case, what's the minimum? Oh, sorry. In this case, let's say, I think it's a minimum, yes? It's a minimum. Okay, minimum. Okay, so you want to find when this is going to be a minimum. So the shortcut is going to be, you can stay with this one. I've given this one, it's not a big deal. You differentiate it. You just use the chain rule and that would be the same thing. But this is the way I do it. I'm going to define a new function, define f of t to be equal to the s of t squared. So quickly that radical would disappear, and that makes things so easy for me to continue. It's the same thing. If you don't like it, stay with the one that we have. Okay, now differentiate it. Find the f prime of t. Differentiate, easy. So instead of the minimum, find the value of the t for the original one, find it for this one. So it's going to be 742t minus 3,920. You let it equal to the 0. Okay, if you let it equal to the 0, this means you have to solve this equation. And if you solve it for t, it's going to be t equal to 3,920 over 384.74. So the result would be 5. So t would be 5, the candidate, to give us a minimum, okay, the minimum values. And to see that this is going to be 1. Yeah, for the maximum, the minimum is the same thing. But you see, you're not done. You have to confirm it that this is a minimum. Any suggestion? I'm going to confirm that t equal to the 5, you get the minimum. Confirmation is going to be, yes, very good. First derivative or the second derivative test. Of course, second is easier. You see the second derivative is going to be, so you have to confirm f double prime of t is just what? Is 784. It's positive, you know that. Second derivative give you the concavity. Positive means it's a concave up. So you are going to get the minimum. So at t equal to the 5, the function, okay, by the second derivative test, at t equal to 5, f of t or s of t, s of t has a minimum. Okay, so it's very, very popular. In your book, you have 3 or 4 problems regarding this type of, this type of ideas. And so just check it. You have one more in your practice one, and you have one in your extra one that it's missing so far, but it's going to be coming. So make sure you know it and write it down. If you don't like this method, when you differentiate it, you see, there's going to be a radical type. It's going to be rational function. So the top would be 0, the same type. That's easy. Just using these type of ideas rather than the original one that you're going to have. So the rest are going to be straightforward to be able to get it. Okay, so this is the minimum. So you have a couple of functions to differentiate, to integrate. I just do one integration for you, just to warn you that you may need integration by parts. Okay, what number was it? I think that's the number 15. You want to integrate. So we give you one integral, one limit, one continuity domain. You see, that's one. That's a part 1 that I want to make sure you remember this. Okay, you want to find this integrate. Okay, integrate. You see the this is the integral of e to the 5ti plus 8tj plus ln of t times k all dt. You see, they ask you to find this integral. You know that you break it into the component and you do it. So this integral would be changed into, okay, so you have to find the e to the 5t dt times I plus integral of 8t dt times j plus integral of ln t dtk. This is the way you have to do it. And they are improper integral. So you need a constant c. If it's going to be definite, you're going to do the definite. So we do it one by one. So we do the first one, e to the 5t dt. That's easy. Exponential function never change. It's e to the 5t. You know that you have to multiply by u prime. U prime is 5. So that gives you the first one. Okay, derivative of, you know that the derivative of e to the 5t is e to the 5t times 5. When you integrate it, you divide. That's first one. The second one, 8t dt. That's easy, 8t squared over 2 plus c2. You simplify that, give you 4t squared plus c2. That's the second one. This is the third one. That is different. The third one is ln t dt. You know that you have to apply integration by parts. Okay, and it's up here. ln t, t ln t are the popular example that we need. Okay, remember the integration by part. We take the u to be ln t and the dv to be dt. That's the way we do it. So we find the other parts, differentiate the first one, du would be 1t dt. You integrate the second part, v would be t. Just applying the integration by parts method. So the original integral ln t dt would be uv t ln t